try that again. I can use scatter plots to describe patterns and relationships. So a scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. So let's take a look at example number 1, making a scatter plot. The table right below shows the average fuel economies of 8 registered vehicles. It says make a scatter plot of the data, identify any outliers, gaps, or clusters. So let's take a look at this. I'll first label my axes. I'll label this as age, years, and I'll label this as fuel economy, miles per gallon. Okay, so step 1 is let's make a scatter plot of the data. So what you have to do is plot the points. So I'm going to take some time and plot the points. For my x's, I'll go up by 1s. And then for my y's, I think by 4s are okay. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and 48. So let's plot all of the points. So 2, 31 is going to be roughly right here. What's the next one? 3, 23. 3, 23 is going to be like right here. 1, 32. 7, 20. 2, 48. 9, 18. 2, 24, and 3, 29, right around there. Looks all right. All right, and then it says identify the outliers, gaps, or clusters. So outliers, let's start with that first, are data points that just kind of like outliers, right? They don't belong, I think is a good way to say it. And I would say this point right here really doesn't belong. So I would label that as my outlier. Next, a gap. A gap in the data is pretty self-explanatory. It is when you see a large gap between any data sets. So I would say here is a gap of the data. And then a cluster is where there's a bunch of points kind of grouped together. So I would label this as a cluster. So that is outliers, gaps, and clusters. Right? So what is a scatter plot useful for? Well, a scatter plot can show a relationship between two data sets. So this example right here is what we call a positive linear relationship. So what that means is the points kind of lie in a line, and as x increases, y also increases. This one right here is a negative linear relationship. Why? Because as x increases, y decreases. So that kind of has a negative slope. This one right here is a non-linear. Why? Because it looks like kind of like a curve, right? So the points approximate the shape of a curve. The last one is what we call a no relationship. Why? Because there's really no pattern, right? There's no pattern in any of the data. Okay. So example number 2, describe the relationship between the data and the scatter plot. Well, if you take a look, they kind of are in a straight line. So I would label this as a positive linear relationship. Okay, moving on. The closer the points are together, so in addition to the positive linear, negative linear, and everything, the closer the points are to a line or a curve, the stronger the relationship will be. So for example, take a look at this one. This one looks like a negative linear, but I would also label this as a strong linear relationship. Why? Because they're closer together. This one is a weak linear. Why? Because it still is generally formed in a line, but it looks like it's a weak relationship because it's not as close together. This one right here would be a strong non-linear relationship, and this would be a weak nonlinear relationship. So, using this information, let's describe the relationship here. Which of the following best describes the relationship between the data in the scatter plot? Well, I mean, if you were to kind of sketch a pattern, right? If you were to kind of sketch something, it would look like this. So it kind of looks like a curve, right? So the points aren't really close together, so I would call this a weak nonlinear relationship. Okay, so using this, why don't you try this real quick? The scatter plot on the right shows the ages of 12 people and the number of pets each person owns. Describe the relationship between the data. Looks like this one to me is a non-linear relationship. There really is no general pattern or trend that I can come to a conclusion of based off of this data that I'm given. All right. One more example. It says example number 4. The table shows the amount of fat and the number of calories in 12 restaurant sandwiches. How many grams of fat do you expect in a sandwich that contains 650 calories? All right, well, let's take a look at this. Remember, I would label this as your X, label this as your Y. It says use order pairs X, Y, where X represents grams of fat and Y represents the number of calories, then make a scatter plot. So what I would do, let's first make a scatter plot first. I will label this as fat, grams, and then this one is calories. Taking a look at my numbers, maybe I'll go up by 5s for my X's. And then for my Y's, I don't want to go up by such a big number. So maybe I'll start with a break in the graph like this. If you draw a little squiggly at the bottom of the graph, that represents a break. And then I'll start at 400, and then I'll go up by 50s. Okay, and now I could plot my data points. So it looks like 12 is about 470. So right around like 29, 540. I would put that right around here. 10, 420. 42. Oh, that was weird. 42, 740. 30, 600. 33, 640, 44, 790, 22, 510. Okay, so there is my data. And then it says, how many grams of fat do you expect in a sandwich that contains 650 calories? Well, one thing that I think might be helpful is if you were to kind of draw, and this will kind of get into tomorrow's lesson too, but draw a little bit of a line that kind of is centered between all of them, right? So it looks like you don't have, most of the points are kind of close to that line. You have some points that are above, some points that are below, but that's okay. But I would say that's generally close. Why would I be doing this? Well, then it's easier to spot out. 35 calories looks like roughly 650 calories. 600, yeah, so 35 grams of fat would be roughly 650 calories. So that's what I would assume for this as well. Okay, so why don't you try this next one on your own? Maybe I will go by 0.5s for both your X and Y, and then we'll see where we are. So I will label this as your X, this is your B. Zero, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 6. Same thing on my X's, or my Y's, excuse me. Okay, now if I were to plot all the points, 2.6, 2.4 would be like right here. 2.8, 2.5, 3.2, 3, 4, 3.6, 3.8 comma 3.5, 1.7 comma 1.6, 3.5 comma 3.6, 3.5 comma 3.4, 0.8 comma 0.7, 1.4 comma 0.5. So I would say that's roughly about it. If you were to draw a line, it looks like this is as close as possible as you can get. Doesn't have to be perfect, right? So if town A is at 2.7 inches, it's like right around here. But would town B be at? Well, depending on where your line is drawn, I would say maybe like 2.5 through 2.6 inches, give or take. All right. So that is it for today's lesson. Circle level of understanding.